Okay, welcome to the work solutions for the Edexcel Higher Tier, June 2011. It's a non-calculator. I have, however, gone through it and written some answers already, so I'm a bit quicker for you, so hopefully it won't take you too long. So watch the video and check your answers. Don't forget, we've got the formula page there if we need it. So, question 1. List of ingredients for 10 flapjacks. Given there, work out the amount you need for 15. Well, 15 is just half as much again as 10. So all we're doing in this case is adding on half as much again. So 80 will become 120. Half of 80 is 40. Add that on to the 80, gives you 120. And so on for each of those. There's your answers. Okay. Question 2. Harriet retake books. It's basically scatter diagram. Describe the relationship between the number of pages in the book and the time Harriet takes to read it. As the pages increase, the times increase. So the words we're looking here for in terms of the exam are positive and then correlation. That's all that's needed. We don't need as one goes up, the other goes up, just looking for the word positive and correlation. The next bit, estimate the time it takes for Harriet to read it, and that's for a book of 150 pages. It's worth 2 marks, so you can't just guess. What we're looking for here is a simple line of best fit drawn on the graph, which I shall do now. That's my line of best fit. It used to be about there, doesn't be exactly there. I'm now going to rule up from there at 150 pages, which I'm going to do now. And then rule across from there where that was, which is there. And now I can read off what this here is. Now work it out. That is 2 squares, so that would be 1, so it's going to be 0.2, 0.2, 0.4, 0.6, 0.8, 1. So here, that's going to be 7, 0.2, 0.4, 0.6, so it's 0.5. So it's 7.5 hours. It's asking in hours, sorry. It's asking in hours, so just leave it in hours. Don't convert that 0.5 into 7 hours and 30 minutes, just leave it at 7.5. Okay, question 3. Angle question. They're asking here for angle X. They've told you it's parallel. They're telling you to it's parallel there. Find the size of angle marked X. Well, it'll be the same as that one there because it's corresponding angles. So it's 55. There we go. And the reason is it's a corresponding angle. Simple as that. Work out an estimate for 7.19 times 19.7 or 0.46. When we're asked for an estimate, we're expecting to work to one decimal place. Sorry, one significant figure. So this becomes 7 times by 20, because I've rounded them both up to their respective one significant figure values, and 0.46 will be 0.5. 7 times 20 is 140, so approximately, which equals 140 over 0.5. Dividing by 0.5 is equivalent to timesing by 2. That's the thing we remember a lot. How many 0.5s are there in 140? Well, it'd be double 140. 280. So my answer is 280. Okay. That was question 4. Here's question 5. Here's the expression h equals 5t plus 5t squared plus 2. Work out the value of h when t equals negative 2. So I've got 5, and instead of t, I've got negative 2. So put it in the brackets, squared plus 2. Negative 2 squared is 4. 4 times 5 is 20. Add the 2, gives me 22. Work out the value of t when h equals 47. And this time they're giving me the answer, and I've got to work back to t. So I'm going to do a little flow diagram to help you here. We start with t. The first thing we do to it is square it. So I've just written x squared there like it's in a calculator. Then we times it by 5. And then we have to add 2. To undo that process, we would first need to take the 2, then divide by the 5, and then do the square root. And again, I've just used x there, the square root button on the calculator. It will give us t. Well, we know that h, in this case, it was 47. So 47 take 2 is 45. 45 divided by 5 is 9. 9 square rooted is 3. So t would be equal to 3. Okay. N is an integer. Write down all the possible values of n. Well, between -1 and 4. So I'll split -1, 0, 1, 2, 3, 4. I've just listed them there. I'm not going to look carefully at the signs. -1, can I include it? Yes, I can. 4, it's got to be less than 4, so I can't actually have 4, so I've crossed it out there. So my answer is -1, 0, 1, 2, 3. Important word in here is the integer. Integer means whole number. Question number 6. Each exterior angle of a regular polygon is 30 degrees. Work out the number of sides of the polygon. Basically, if you have a polygon, the exterior angle is this angle here that I'm marking each time. Now, if each of those is 30, how many do you need in a whole turn? It's going to be 360 degrees divided by 30. How many 30s in 360? How many 3s in 36? It's 12. So the number of sides is 12. That would be a dodecagon. It's not actually asking you for that, but you might as well learn it now. 12 solid shapes, dodecagon. Okay, nice bit of transformations here. On the grid above, reflect the shape A in the line x equals -1. So the first job is to draw the line x equals -1. Lots of you struggle with that. X equals -1. The only rule you've got of that line is the x coordinate has to be -1. So I could have -1, 5, -1, 3, -1, -2. In all those is -1. If I plot those now, -1, 5, -1, 3, and -1, -2. So I can see that my line is going to be down here. Now I'm going to draw it slightly off the line just so you can see where it was. There we go. That line there. Now I'm asked to reflect that shape A in that line. Again, I forgot my tracing paper, so I may do this bit of plastic. I'm going to trace the shape quite clearly. And then I'm going to trace the line as well. And I also have that little cross marks on there already. Now just flip it over. There we go. That is where the shape is going to be. So there, 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 and there is the point. So I can now just draw that in very simply. Okay. I might in the exam just shade it as well so it's clear to see exactly where it is. The next bit, describe fully the single transformation that will map P onto Q. Now be careful here because naturally our brains, the way we read in the Western world, we go from left to right, so we think we get from there to there, but we read it carefully. It is from P to Q. Get from there to there. Trace my shape. And it's the hop little bunny, isn't it? Okay, hop little bunny, hop, hop, hop. 1, 2, 3, 4, 5, 6. Hop little bunny, don't you stop. And then 1 down. So it's 6 backwards, -6, and 1 down, -1. That's the movement I made, and that type of movement is of course called a translation. So it's a translation, -6, -1. Doing well here. Okay, Sophie wants to find out the amount of time people exercise. She'll use a questionnaire. Design a sort of suitable questionnaire for her to use. You must include some response boxes. Right. So I'm going to go for, try and write neat. How many hours each week do you exercise? Now it's really important. I must have a time limit, and I've said here each week, so I've got my time limit in there. I've also got to have some boxes. So I'm going to do 0 to 2 hours. Now be careful, it doesn't overlap my boxes here. 3 to 4 hours. 5 to 6 hours. It doesn't really matter what you choose, so long as they don't overlap. And I always like to have at least 5 boxes. 7 to 8 hours, and then finish it off so that all times can be included. It must be more than 8. More than 8. So I've got how many hours each week, so it's time limited. Sophie asks people at a swimming pool to complete her questionnaire. This may not be a suitable sample. Give reasons why. The sample will, of course, be biased. And that's because she's already asking people that are at the swimming pool for exercise. The sample will be biased as people are only at the swimming pool, at the pool, to exercise. We'll assume it's not the Olympic Games and they've gone to watch, because generally speaking, people go to the swimming pool to swim. Okay. Number 9. The nth term of a sequence is given by 3n plus 1. Work out the first 2 terms of this number sequence. So we're starting with n, we're timesing by 3, and then we're adding 1, and that'll give us the value. So when n is 1 times 3 is 3, add 1 is 4. When n is 2, 2 times 3 is 6, add 1 is 7. Put a comma between them so it doesn't look like 47. Here are the first 4 terms of another number sequence. Find in terms of n an expression for the nth term of this number. Well, it's going up in 4s. So it's going to be 4n. I like adding on the 0 term. What would be 4 back from there would be minus 3, so it's 4n minus 3. Other people like to write their 4 times table, 4, 8, 12, and then work out what's missing. That is obviously, if you do your 4 times table, you want number 4, you're getting 4, so it's 4 too many. You're getting 8 when you want 5, sorry, so it's 3 too many, so that's also 3 too many. You're getting 12 when you want 9, that's 3 too many, so each time you've got to take off a 3. So the rule is 4n minus 3. Don't forget there won't be a 0 term in there. Okay. The diagram shows the cross-section of a solid prism. The length of the prism is 2 meters. Notice straight away that's in meters, these are in centimeters, so I'm going to need to take care. The prism is made from metal and the density of the metal is 8 grams per centimeter. Work out the mass of the prism. So it's per centimeter cubed. Right, first thing I've got to do is find the volume. That's 2 by 7, that's 7, 2. If I was to cut it off there, that would be 5, that will give me there an area of 10, and this would be an area of 14. So I've got 10, add the 14, gives me an area of 24 centimeters squared, and that's a cross section. I then got to times that by the length of the prism, and be careful, 24 times, now it's not 2, it's times 200, because it was 2 meters. That's going to equal 4800 centimeters cubed. Now, that's the volume of it. I want to find the density, the mass. So I'm going to need to know the density and times those two together. So I've got 4,800 centimeters cubed at 8 grams per centimeter cubed. Times that by 8. Now, it's not a calculator. I would do 1 lot is 5800, 2 lots would be 9600, 4 lots 920, I'm just doubling each time, 384000. There we go, answer 38400 grams. Make sure you put it in there. You might want it to go on for 38.4. Sorry, too late if you wanted to. That seems about right for me. Great big long bit of metal that size. Should be just about liftable. 38 kilograms, just about liftable if you really try. Okay. Peter, Tarish and Ben share £54. Tarish gets 3 times as much money as Peter. Ben gets twice as much money as Tarish. How much does Ben get? Whoa, like a tongue twister that. Let's write it down. Peter, Tarish and Ben. Sorry, that doesn't look like a T. There we go. Right. Tarish gets 3 times as much money as Peter. Right, so if Peter gets 1 share, Tarish needs to get 3 shares. Ben gets twice as much money as Tarish. Right, so if Tarish gets 3, Ben's going to get 6. So our total, 6, 9, is 10. Okay, we've got £54 to share 10 ways, so each part is going to be £5.40. And Ben gets 6 times that, so Ben is 6 times £5.40. 5, 6 is 30, add 240, £32.40. There we go. Okay, number 12. Simplify. W to the power 6 times W to the power 4. Adding indices when we are multiplying. Dividing, we're going to subtract the indices. So 8 take 3 is 5. So h to the power 5. Okay, completely simplifying. I'm going to write this out so we can see it clearly. Okay, well, those will cancel. 1x will cancel with that x there. Sorry, that x on the top will cancel with the squared bits, we'll get rid of the squared. The 12 will cancel with the 3 to give me 4. So what am I left with? 4 on the top there, and just the x on the bottom. Answer 4 over x. Okay, they will show some information about the weights in kilograms of 1,000 boxes. Right. Okay, they want us to draw a frequency polygon to show this information. Right, when I do this, I just draw the boxes on, because too often I find people forget that they need to plot the midpoint. So I'm just going to draw these boxes on in the right places. I should really be using a ruler, but I don't want to spend too much of your time watching stuff you can already do. So I'm just doing that simple there. That's going to come down to there. You may think I'm doing this very quickly. I'm just plotting on here. I actually did it earlier, so that I could do this a bit quick to show you. So I've drawn my frequency density diagram. For a frequency polygon, I just take the midpoint of each block and join them up neatly with a ruler. Okay. There we go. It's a bit inaccurate, the last one, sorry. Notice it just floats in the air. We don't connect it to the bottom. You use a marker to do that. It just floats up in the air there. That's done. Okay. Right. I'm going to really struggle to do this because I have left my compass in school. Basically, use your ruler to construct an angle of 30 degrees at P. You must show all your construction lines. Well, I haven't got a compass, but I'll show you what I would do. I'm using the fact that in an equilateral triangle, I have 60 degrees in all the corners, but I'm going to use the bottom corner here. I can then cut that in half, and that will give me 30 degrees. So to do that, I would get my compass, and I would draw a line of equal distance. Just thinking I could probably cheat with this memory stick here. So I'm going to put that on the end there, that there, that's my line there. Then I will draw a nice big arc. I'm going to guess where it is, which is about there. And I'll be doing that with my compass to get a nice big arc there from the same point. I will do from the same from this end here. I will do a nice arc as well. And as you can see there, they didn't quite cross, but they could have crossed about there if I'd have had a compass properly. So there I've drawn my equilateral triangle. Let's just draw that in like so. Okay, it's not quite as accurate as it should be, but it'll do. Okay, so this angle in here is now 60 degrees. I'm going to mark it as 60 degrees. It's worth 3 marks, so I've probably got at least 1 mark so far, particularly if I'd used a compass. Okay, right, next problem, I've got to split that in half. So for this one, we'd be using a compass at a smaller distance probably. I'm just trying to see what I've got. I've got my rubber here. That could do. In fact, why not use the end of the ruler? If I was to mark off with the compass one line there, and keeping the compass the same, draw around to there. This is called the angle bisector. Keep the compass the same, and then do an arc from that distance. A nice arc like that will be going. So I'm going to estimate that it's about there. So that arc will be going something like that from that point. And I'm going to do the same from that point, and I will just join through there like so. Sorry, that's not so good. Okay, question 15. Expand, and that means multiply out. You must learn that word expand means multiply out. X times x, x squared. X times 2, 2x. Dead easy, dead quick. Okay, expand and simplify. As you know, I really like the grid method. So guess what? I'm going to use it. X times x, x squared. No, it's kissing brackets, therefore use the grid method. 3x, and it's a plus 3x. 4x, but it's a minus. 4 times 3 is minus 12. So I've got x squared plus 3x minus 4x minus 12. I always urge you to write that out like that there. Get a mark for having written that. I'm not convinced you'll get the mark if they see it in the table. It's written as a line, you'll probably get the mark. X squared minus 1x minus 12. There we go. Completely factorise. So what's common to both of these? Well, there's a y. So take my 2y outside the bracket. I have to times it by y to give me 2y squared, and I have to times it by minus 2 to give me minus 4y. So the answer is 2y brackets y minus 2. Okay, factorise this one. Now this is not a tricky one, but it's called a difference of two squares. You need to recognise that when you get an x squared, or the letter squared, and then a minus square number, and minus a square number, it's a simple case of the difference of two squares. X and x, the square root of 9 is 3, and 3, 1 is plus, and 1 is minus. There we go. Okay, work out 2/3 divided by, you might be struggling to see that on here, divided by 5/6. I'm going to use the KFC method, so keep the first, flip the second, change the sign, KFC, keep it, flip it, change it. Okay, 15, 3 times 5 is 15, 2 is 12. That's the answer, but notice it said in its simplest form. I can cancel that, both in the 3 times table, 4 over 5. Okay, second part. This, take away that. I'm going to convert those to top heavy fractions first of all. So 3 times 2 is 6, add the 1 is 7. So 7/3 is the same as 2 and 1/3. 1 times 5 is 5, adding the 2 is 7, 7/5. So my calculation has now become this. They're different denominators. I could use a picnic table, couldn't I actually? But I'm not going to, I'm going to do it the other way this time. I'm going to say I can change them both to 15ths. So that's 35 over 15 minus, I've times the bottom by 5, so I've times the top by 5. I've got times the bottom by 3 to give me the 15, and the top here I've got a times by 3 as well. 21 take away from 35, it's going to give me 14 over 15. There we go. So what I'm going to do, I'm going to be kind and show you the picnic table method as well, because I know some of you are relying on that. Okay, boom, boom, boom. Okay, 3 5s on the bottom is 15, 3 times 7 is 21, 5 times 35, take them away, 14 over 15. Woohoo, get there the same way both times. Okay, oh, halfway. God, it's been half an hour as well. Right, keep going in. In the diagram, ABC is a triangle, ABC, ACB, ACB, that there's 90. P lies on the line AB, CP is perpendicular to AB, CP, perpendicular, right, so that's a right angle in there. Also means that in there will be a right angle, don't forget, that'll be useful in a minute. Here we go, prove that the angles of triangle APC are the same as the triangles CPA. Right, okay, this looks really complicated, but they've both got right angles in there. So I've got one angle proved already. That means I've only got to prove that two other angles match, and then the third one must obviously match because that's all that's left in the 180 degrees. So let's go for it. In triangle ABC, angle B is equal to 180 minus the 90 at C. Take away the A. Okay, which equals 90 minus A. 180 take the 90 is 90. In triangle APC, I'm using APC this time, C is equal to, and I'm just talking about this little bit here now, this little angle here, C, is 180, the whole triangle, minus 90 at P, minus A. So C equals 90 minus A. So I've now shown that this angle is the same as this angle here. So in angle APC, sorry, is the same as that angle there, B. That's what B equals. So this angle and that angle are the same. Given they're both right angles, the remaining angle, which is this one here, and that one must also be the same. So APC equals 90 degrees, and CPB, put the angle sign in, equals 90 degrees. So that's in this triangle, and in that triangle we've got one right angle. Angle B here is 90 minus A, and angle C here is 90 minus A also. Therefore, all angles are the same. Okay, sorry, didn't quite let you see that at the end there. Blank page. Okay, the table shows information about, I'm just going to turn the light on it, there we go, shows information about the time it takes to show 120 films. Write down the modal class. The modal is the most often, so the highest number here is 34. A modal class, just copy that exactly, 90 and 100. Very easy mark. Complete the cumulative frequency curve. Write the cumulative frequency table. That means you need to add up as you go along. So up to 80 is 4, it's already done for you. Up to 90, 70 up to 90 is going to be the 4 there plus the 12, gives you 16. Everything up to 100, 70 up to 100 is going to be the 4 plus the 12 plus the 34 and so on. And if you do that, add them up as you go along, you'll end up with a total of 120. On the grid, draw the cumulative frequency graph or cumulative frequency table. Okay, really important. Cumulative frequency, cross out the first. So back to my table. I'm not going to plot that, I'm going to plot the endpoint. So let's just work it out here. Each little square is 1 going along here, but that's 20. So each little square is 2. Okay, then you need to go and plot your points. 80 and first one was 4. 80 and 4, no, would be there. The next one, 90 and 16. 90 and 16 is going to be there. Okay, what I've actually done is done that already, just to speed it up for you, but you could plot those points. Then, nice smooth curve, drawing those up. I missed one there, let's not panic too much. If you do it in pencil first of all, in the exam we'll be able to change it. Last bit, use your graph to find an estimate for the median. Where there are 120 people, we want to look across at 60 because that's the halfway point, the middle point, the median. Again, I'm going to go just below the line so you can see where it's come to. There we go. And that is crossing my line there. So I'm now going to read down from there. What do I get? 103, 4. 100 and... oh, that's really stupid. 103.5 minutes. There we go. should be a straightforward question really. Nothing complicated in that one. Okay then, solving the simultaneous equations. 4x plus y equals 10 and 2x minus 3y equals 19. When I started doing this I was really tempted with the first one, but then I decided if I had 4x plus y was equal to 10 and then 2x minus 3y equaled 19, it'd be nicer if I added these two together to cancel out my y's. So I ended up tripling the first. So triple the first one, let's call that a, so 3 lots of a, 12x plus 3y equals 30. Then underneath it I'm going to recopy equation b, which was 2x minus 3y equals 19. I'm now going to add those up. 14x, no y's, equals 49. Well, 7 times table 14, and x is going to be 3.5. So I already found out what x is. I'm now going to use that value of x in this first equation again. So copy out the equation, 4x plus y equals 10. If I use that value of x, it will only leave me with the y as the unknown, so I better find it. 4 times 3.5 is 14, so 14 plus y equals 10. Y must therefore be negative 4. I'm now going to check those two values in this final second equation here. So 2 lots of my x value, which is 3.5, minus 3 lots of my y value, which is minus 4, gives me 19. Is that true? 7 minus negative 12. 7 add 12 is 19. That is indeed true, so I'm happy I'm right. X is 3.5, y is negative 4. There we go. You can play that again slowly if you need to. Okay, 20. Box plots show information about the points scored by some students in a spelling competition. Lucky them. Compare the distribution of the boys' scores and the girls' scores. Right, straight away, median value here is the same. So I'm going to write the average. I've put that in quotes there because we tend to misuse that word in English. I.E.median boy is the same as the average girl. Okay, however, now look here, the middle 50% of girls are much closer grouped than the middle 50% of boys, and in fact all the girls are much closer than all the boys. So, however, girls are much more consistent than boys. There we go. The line L is drawn, work out the gradient of the line. Right, so for every one square we go along, one square, we've gone down half a square, 1 square. The scales are 1 to 1, so the gradient is a half. I go down half a square for every square I go along. Another line M is parallel to L and passes through the point 6, 2. Right, 6 along, 2 up is there, and we've got to be parallel to that. So it's going to have the same gradient, which is through those points there. Let's try and line that really neatly. There we go. Find the equation of the line M. Well, the gradient, y equals, the gradient we know is going to be minus a half x. And where's the intercept? Where does it cut y equals 0? X equals 0 there. 5 plus 5. So the equation is y equals minus a half x plus 5. Right, find the value of 27 to the minus 3 over 2. I love these. Sorry, 2 over 3 it was. Right, first of all, we've got 3 things going on there. We've got the negative bit, which is a reciprocal. We've got the third bit, which is a cube root. And then we've got square, which is a squaring. So I'm going to do it one stage at a time and unpeel it like an onion skin. So Instead of writing 27 to the minus 2 over 3, I can write that as 1 over 27 to the 2 over 3. That's my first stage. I can then say that's the same as 1 over the cube root of 27 squared. I've got rid of the third bit there. So I'm going to do that because I can do the cube root of 27. Something times something times something gives me 27. 3 times 3 times 3 is 9. Sorry, 3 times 3 times 3 is 27. So it's 1 over 3, that's that cube root of 27 bit, squared. 3 squared we know is 9, so it's 1 over 9. Answer 1/9. I like that. Okay then. Given that 8 minus root 18 all over root 2 equals a plus b root 2, where a and b are integers, find the value of a and the value of b. That's a really complicated way of saying rationalise the denominator. Now here, we can see there's no denominator. Sorry, no irrational denominator, no fraction. So let's just go for that. So 8 minus root 18 all over root 2. I need to times the top by root 2 and also the bottom by root 2. That will give me 8 root 2, that's that root 2 times there, but I've also got times by the 18 as well, minus root 2 root 18 all over root 2, which of course is 2. So that's going to be equal to now 8 root 2 minus the square root of, I'm going to put it all under 1, 2 times 18, all divided by 2 times root 2 is 2. 8 root 2 minus the square root of 36, because 2 18s are 36, all over 2. And that's going to be equal to 8 root 2 minus 6, all divided by 2. Okay, so that's going to be 4 root 2, because 8 divided by 2 is 4, and 6 divided by 2 is 3, minus 3. Let's just rewrite it in the order they had. So it's negative 3 plus 4 root 2. So in this case, A is minus 3, and B equals 4. That wasn't so scary after all. Sorry, there we go. Okay, make K the subject of the formula. This is quite a tricky one, to be honest with you, but let's show you. T equals K over K minus 2. The problem is we've got the K occurring twice. First thing I'm going to do is get rid of the fractiony bit. So I've times both sides effectively by K minus 2, by this bracket K minus 2 on the bottom. It's cancelled out on this side, so I've got T into K minus 2 equals K. Now times that bracket out, TK minus 2T equals K. Next bit, I'm worried at this before I got it wrong. Nope, did get it wrong before, but I'm going to get it right now. Okay, equals K minus, I'm going to take this from both sides, TK. And that there should have a T in it, don't forget. That's where I went wrong before. Okay, so this side stays the same, 2T equals, now I'm going to factorise this K into 1 minus T. K times 1 will give me K. K times minus T will give me minus TK. The reason I've done that is I've now got K isolated by itself here. So minus 2T over 1 minus T, I've divided both sides by this, is equal to K. Just divided by that bracket on both sides. There's my answer. My answer is minus 2T divided by 1 minus T. A bit cross I got that wrong the first time I was working through it, like I noticed. Okay, histogram. Incomplete table, and the histogram gives some information about the height of some flowers. Use the histogram to complete the table. Alright, right. This histogram, the first thing I need at some point is my frequency density column, so let's just add one on there a minute, because that'll help me as I go along, I'm sure. Right, frequency density is equal to the frequency divided by the class width. So what should the frequency density here be? Class width there is 30, 30 frequency, so 30 divided by 30 is 1. So I know straight away that this here must be 1. They plotted it for me, so that there must be 1. That's 2, 3, 4, 5, 6, and so on, because the scale must be equal. Okay. First thing I'll do is complete the table. So this here is 4.2. Okay, so I need something divided by, the width there is 20, something divided by 20 is 4.2, or double 4.2 is 8.4, 84. That there must be 84. 84 divided by 20 is 4.2. The next one, frequency density is 6, something divided by, the class width there is 10, something divided by 10 is 6, that must be 60. Okay. Completing my frequency, now I've got to complete these two here. 40 divided by 20 is 2, and then 18 divided by 30. That's looking hard, but let's write that down. 18 over 30, this is where fractions can actually be useful to you. Divide the bottom by 3 is 10, divide the top by 3 is 6. I could cancel further, but I like the idea of 6 tenths because that's 0.6, and 0.6 I can plot on the graph. Right, 0.6, that was that last group, is there. So that's going to have to go across to there. Should have used a ruler, sorry. And the other one, 0.6 in there, was 2. A bit more straightforward. And the other one there is 2. And let's just do a bit of shading so the examiner knows exactly where I'm meant to be. There we go. Okay. Right, this is the first higher paper I've actually done on a video, and this gave me a bit of a panic when I saw it, but I'm sorted out now. Right, it's telling you that the surface area of this shape, when you've read this, is the same as that one there. And I started getting a really complicated formula because I was including the bases, but the bases are the same, they're both pi x squared. So I don't actually need the base bit because they are equal to both already. So, this one's easy. The surface, a curved surface area of that hemisphere. If you go back to the very start of the paper, you'll see here that you've got the surface area of a sphere is 4 pi r squared. We've only got a hemisphere, so we've got half of it. So the hemisphere, HS, is going to be 2 pi. Now in this case, r is x squared. Now the curved surface area of the cone, you're not worrying about the bases because they were the same, so we've only got to worry about the curved section on both. Again, look here, curved surface is pi r l. I'm just going to write that down here, the cone is pi r l. Now we don't have this distance l down here. I'm going to have to use Pythagoras for that, and that's going to be x squared plus h squared. So l is going to be x squared plus h squared, and then don't forget, square root it. I've then got to times it by r, the radius, which was x, and then by pi. So that is the curved surface area of the cone, and that's the curved surface area of the hemisphere, and they are equal to each other. Right, well, the pi's cancel out, and look, so does one of the x's. So I'm left with root x squared plus h squared equals 2x. Just go back and check out that right. Yeah. Okay, so then square root both sides. Sorry, square both sides. I need x squared plus h squared. That gets rid of that square root. It's going to be this side squared, so 4x squared. Now I've got an x squared there, and 4x squared is there. So take one x squared away, I'm left with h squared equals 3x squared. Now h will therefore be the square root of 3x squared, which is the same as the square root of 3 and the square root of x squared. And the square root of x squared is just x, so h equals, and I'll probably put the x first, x root 3. I haven't got a mark scheme, but I hope that's right. Should write it on the line there, but I'll just draw it over. Okay. I love these vector questions, so I think they're quite straightforward normally. And they tend to be at the back of the paper. It's nice to get one. Right. O to A is 2A. O to B is 3B's. Find A to B in terms of A and B. I want to go from A to B. I am going to get my highlighters out. I can't resist it. Let's just plonk them on, because you know that movement there, and you also know this movement here. Okay, you can't walk in a bit you don't know, so you can't walk in a snowman land to get from A to B. How are you going to get from A to B? You're going to go back along there and out along there. So that's quite simply minus 2A plus 3B. And we probably write that as 3B minus 2A, just to be neat. 3B minus 2A. I'll tell you what, question 26 out of 27 on a paper. That's an absolute gift for a mark at this point in the paper. Right, P is a point on AB such that A to P to B, P to B is 2 to 3. Right, usual stuff. That's 2 units. That's 3 units, so a total of 5. So it's 2/5 of the way along. Show that O to P is parallel to the vector A plus B. Let's not get too ahead of ourselves. Let's just work out what O to P is first of all. Then we'll worry about showing it's parallel or otherwise. So we want to go O to P, dead simple. Out to there and along here. Now we know what this one here is already. We know A to B. We should have marked that in green. I forgot. We know A to B, and this is bit here. We've got that already. So that's dead simple. It's going to be the orange. So O to P is the orange O to A plus. Now it's only 2/5 of A to B. If you really want, I'll colour it in for you. Boom. It's the orange bit plus 2/3 of the green bit. There we go. Let's just write down what that is. That's 2A. O to A is 2A plus 2/5 of the green. We worked at the green, it was down here. 2/5 of 3B minus 2A. Okay, simplify it. Right. 2 times 3 is 6, so it's 6/5 B minus 4/5 A. Right, collect the terms, 2A and minus 4/5 A. That's going to leave with 1 and 1/5 A. Sorry, 1 and 1/5 A. We haven't messed about the B, so it's 6/5 B's. Now 1 and 1/5 is again 6/5, so 6/5 B plus 6/5 A. Well, we can factorise the 6/5 out and leave it as B plus A. There you go, which is the same as A plus B. If you want to write it like that, you can. 6/5, sorry, I keep thinking that, 6/5, A plus B. Well, that's going to be exactly the same. The direction is the same, it's just further or different. So, therefore, parallel to A plus B, just a scalar of it. That means more of it. Let's scale it up. What a lovely question. Penultimate question on the paper, and it was really quite straightforward if you've done lots of practice of these. And that's what's nice, that's what I love about the vectors questions. You can do lots and lots of practice, and they're nearly always the same. And the final question, likely to be hard. Let's have a look. Solve the equation. Okay. Done a lot of practice of these. This is the algebraic fraction. Don't get scared by it. Let's write it out and just be methodical about it. Equals 1. Right, it's this bit here that's causing us problems. We need to get it into one fraction. Let's add them up. And guess what? We're going to use upside down picnic for this one. We used it earlier on. Let's use it again. So on the bottom, 2 times x plus 1. Just write that as 2 times x plus 1. Okay. On the top, this times this, that's x into x plus 1. And 2 times 2 is 4 minus 4. Don't forget, it's still equaling 1. I'm not going to worry about this 1 for the moment. Let's multiply this out. X squared plus x, done that, and then we've got the minus 4. 4 divided by 2x plus 2, still equaling 1. I'm now going to times by this thing on the bracket, on the bottom over there. So I'll get x squared plus x minus 4 equals, now it's one lot of 2x plus 2. You could put the 1 in there if you needed, just so you can see where it's come from. Just rewrite it without that because it's going to confuse us a little bit. Let's merge the mouse there. Right, here we go. Now then, I want to get it equal to 0 because it's a quadratic. I can only solve quadratics when they're equal to 0. So to have a 0 on that side, I've had to take away the 2x. What x take away 2x will be a minus x. So nothing with the x squared, so that stays there. Now I've got minus 4, take away that 2 will be minus 6. So x squared minus x minus 6 equals 0. Just recap there, I've taken away 2x there, and I've taken away 2 to cancel those out down to 0. I've got a quadratic. Can I factorise it straight away? I think I can. X and x. Now the reason I'm going for factorising is it's a non-calculator paper. You can't use a formula. You're going to have to just do it by factorising, so it must factorise. Two numbers at times together to give me minus 6, and I've got a difference of minus 1. Well, 2 times 3 gives me 6, so it's 2 and 3. It's a bit more negative than it is positive, so x plus 2, x minus 3. So x can be equal to, it's plus 2 there, so it'll be minus 2, equal to, so minus 3 there, so it'll be plus 3. X equals negative 2, or x equals plus 3. Job done. Okay, hope that's been useful to you. I'll just put it back to the opening page, and let's hope I got all of that right. Like I say, didn't have the mark scheme handy with me at home. I hope I've got most of that right. I'm no wizard at maths, but hopefully enough of it's right that's been helpful to you. Thank you very much.